This is the EdExcel A-Level Maths Paper 3, covering the Statistics section, and it's from the 2021 series. Question number 1 for Part A, we have to state one disadvantage of using quarter sampling compared with simple random sampling. The disadvantage of quarter sampling compared with simple random sampling. Quarter sampling is not random. Of course, simple random sampling, suggested by the name, is random. For Part B, in a university, 8% of students are members of the University Dance Club. A random sample of 36 students is taken from the university. The random variable x represents the number of these students who are members of the dance club. Using a suitable model for x, we have to find, for the first part of Part B, the probability that x is equal to 4. Well, we've got a random sample of 36 students. 8% of students are members of this dance club. We can set up a binomial distribution. Of course, each trial is independent, and we either have the probability of success, in this case 8% being part of the dance club, and the probability of failure, 92% not being a part of the dance club. So, if we set up a binomial distribution, x is binomially distributed with parameters 36 and 0.08. So, when we come to find the probability that x is equal to 4, we can use our calculator. If we go to the menu and then the distribution sub-menu, press option 4 for normal PD. Number 2, x is 4, n is 36, p is 0.08. It turns out the probability that x is equal to 4 is 0.167387, etc. And now we have to find, for the second part of Part B, the probability that x is greater or equal to 7. So, the probability that x is greater or equal to 7, this is the same as 1 minus the probability that x is less than or equal to 6. If we go to the distribution menu, binomial CD, variable, x this time is 6, same n, same p. We have 1 minus 0.977, etc. And if we work this out, 1 minus this, we end up with 0.0222 3, etc. Now, for Part C, only 40% of the University Dance Club members can dance the tango. we have to find the probability that a student is a member of the university dance club and can dance the tango. So, the probability that we can dance club and dance tango, well, the probability that we can dance club, that's 8%, 0.08. And then we multiply this by probability that we dance tango, 40%, 0.4. If we work this out, we get 0.032. And now for part D of the question, a random sample of 50 students is taken from the university. We have to find the probability that fewer than 3 of these students are members of the university dance club and can dance the tango. Well, what we'd have to do here is set up a new random variable. The reason for that, we have a different number of university students taken in our sample, and the probability has changed this time. The probability we have this time is 0.032. So, letting the random variable t equal those who can dance club and dance tango, t will be binomially distributed with parameters 50. We've got a sample of 50, and the probability that we can dance club and dance tango, we work that out to be 0.032. What we are looking for in this question is the probability that fewer than 3 of these students are members of the university dance club and can dance the tango. So we are looking for the probability that t is less than 3. Well, this is the same as the probability that t is less than or equal to 2. And if we work this out using our calculator, if we go to the distribution section, binomial CD, variable x is 2, n is 50, and p is 0.032, it turns out we get 0.785081, etc. So the probability that fewer than 3 of these students are members of the university dance club and can dance the tango is 0.785081, etc. Question number 2. Mark took a random sample of 16 students from a school, and for each student recorded the number of letters X in their last name, the number of letters Y in their first name. His results are shown in the scatter diagram on the next page. Here is the scattergram. For part A, we have to describe the correlation between X and Y. Well, what we have is data going down like this. However, these data points are not close to the line. So what we have for part A then is weak negative. For part B of the question, Mark suggests that parents with long last names tend to give their children shorter first names. Using the scatter diagram, comment on Mark's suggestion giving a reason for your answer. Well, let's think about what he is saying. He is saying if we've got long last names, we have short first names. So the longer X is, the smaller Y is. Well, his suggestion would make sense because we have a negative correlation. So Mark's suggestion is compatible because we've got negative correlation. For part C of the question, the results from Mark's random sample of 16 observations are given in the table below. We've got different values of X and Y. We have to use our calculator to find the product moment correlation coefficient between X and Y for these data. On our calculator, if we go to the menu and the statistics sub-menu, press number 2, and then we need to key in the different values of X and Y. So let's begin by keying in the different X values. We have 3, 6, 8, 7, 5, 3, 11, 3, 4, 5, 4, 9, and then we have 7, 10, 6, and 6. If we type in the corresponding Y values, we have 7, 7, 4, 4, 6, 8, and 5, 5, 8, 4, rather. Here we have 5, 5, 8, 4, 7, 4, 5, 5, 6, and 3. And then press AC, options, then number 3. You can see the value of R. So, if we write down that value of R for part C, we have R equals minus 0.54458, etc. And now for part D, we have to test whether or not there is evidence of a negative correlation between the number of letters in the last name and the number of letters in the first name. You should state your hypothesis clearly and use a 5% level of significance. So, for part D of the question, we've got our null hypothesis rho is equal to 0, no correlation. And then our alternate hypothesis, H1 rho is less than 0. Now, what we need to do is find our critical value. On page number 37 of the formula book, we've got the product moment coefficients with different significant levels with different sample sizes. We of course have a sample size of 16. Our significant level is 5%. So 5% significant level with a sample size of 16, we have 0.4259. But of course, we want the negative of that because we're testing if we have negative correlation between x and y. So now let's draw a quick diagram to help with this question. We've got our critical value, RC, equals minus 0.4259. Everywhere here is where we would reject H0. Our value of R, we found this to be minus 0.54458, etc. We are in the region where we would reject H0, so we would reject H0. So we can conclude there's evidence of a negative correlation between the number of letters in the student's last name and their first name. Question number 3. Stav is studying the large dataset for September 2015. He quotes the variable daily mean pressure x using the formula y equals x minus 1010. The data for all 30 days from Hern are summarized by the sum of y equals 214 and the sum of y squared is 5912. For part A, we have to state the units of the variable x. Well, of course, we have daily mean pressure, so the units is HPA. Now for part B, we have to find the mean daily mean pressure for these 30 days. Well, what we need to do is use the coding formula given to us here. Before we do that, we would have to rearrange for x. The reason for that is we are finding the mean of the daily mean pressure, and of course daily mean pressure is given by x. We would have to rearrange for x. So for part B, rearranging for x, x is equal to y plus 1010, and so when we come to find the mean, x bar is equal to y bar plus 1010. Now, can we find out what y bar is? Well, y bar will be given by the sum of the y's divided by the number of pieces of data we have, 30. So we can conclude then x bar is equal to y bar. Well, let's just move this here. We have y bar 2214 divided by 30, and then we will add on 1010, and so therefore 214 over 30 plus 1010, we get 1017.13, etc. HPA. Now, for part C, we have to find the standard deviation of the daily mean pressure for these 30 days. For part C, we are finding sigma x. Now, this is equal to sigma y. What is the reason for this? Well, of course, standard deviation is not affected by this type of coding. Now on page number 8, the formula to work out the standard deviation is given here. So what we can do, of course, using this formula, we would replace the x with y instead. We've been given data for y. So the standard deviation of y, which we know is the same as the standard deviation for x, that's the sum of y squared over n minus y bar squared. So if we work out the standard deviation, the sum of the y squareds, that's 5,912. So we have 5,912 divided by n, which is 30. And then we subtract off y bar all squared. So that will be equal to 214 divided by 30 all squared. And then we square root this result. So if we square root the result, this will tell us the standard deviation of x. And so working all of this out, we have the square root of 5912 over 30 minus 214 over 30 squared. It turns out we get 12.09, etc. So this is the standard deviation of x. Now for part D, staff knows that in the UK, wind circulates in a clockwise direction around a region of high pressure and in an anti-clockwise direction around a region of low pressure. The table gives the daily mean pressure for 3 locations from the large dataset on the 26th of September 2015. So we've got the locations of Heathrow, Herne and Leuchars with their associated daily mean pressure. And we've got the cardinal wind directions for these 3 locations on the 26th of September 2015 given in a random order. You may assume that these 3 locations were under a single region of pressure. We have to use our knowledge of the large dataset to place each of these cardinal wind directions in the correct location in the table, giving reasons for our answer. The confusing bit in this question, in my view, is regarding the clockwise and anti-clockwise directions of the wind. If we've got a clockwise direction, we have high pressure, anti-clockwise, we've got low pressure. But then it also says we can assume that these 3 locations were under a single region of pressure. What does this mean? What we mean over here is we are looking at an entire pressure system. Now, the next question is, if we take a look at our entire pressure system, is our entire pressure system somewhere where we have high pressure or low pressure? That's what we can determine. We know already what the mean is. We also know what the standard deviation is. So with this, we can see if we have high pressure or low pressure. So for part D, to begin with, let's determine whether we have high pressure or low pressure. If we add together the mean and the standard deviation, this is approximately equal to 1017. That's what the mean was. We found that out over here. And then we add on 12.1, approximately, of course. And if we work this out, we get 1029.1 HPa. So, if we go back to these values given in the table, the mean plus the standard deviation is around these values here. So the entire pressure system is a high pressure system. So let's just conclude that the entire pressure system is high pressure. And if we have high pressure, we have a clockwise direction. So we can therefore conclude we have a clockwise direction. So if that's the case, what that means is we are going in a clockwise direction. So we have a clockwise direction going this way. And let's just draw a compass like so. We've got north, east, south, and west. We will be going in the direction we see here. We will be going in a clockwise direction. Now, what do we know about wind direction? Well, regarding wind directions, cardinal wind directions is direction wind is blown from. Now, if we take a look at the map of the UK with our locations, the locations from north to south, we've got Leuchars up here, we've got Heathrow somewhere here, and Herne below it. So, how does this help us? Well, if we take a look at the letters, we've got west, north, east, and east. So, if we take a look at the diagram, we have, to begin with, northeast. So we're going to start from here. Then we go east. So we go here. So this is the second. And then we go to west. So we've got 3 over here. So we go from north, then to east, then to west, because we are going in a clockwise direction. And if we take a look at the map as well, the wind is going here, then here, then here. So we go this way, then here, then back up here. So the wind, if we consider the entire pressure system and then the grey vortex, we start off here at Heathrow in the northeast direction, and then we go here, and then we go back up there. That's the way the wind is going. This is the entire pressure system of the UK in terms of the wind directions. So you can see northeast is first, which corresponds to Heathrow. So this is northeast, followed by east. Remember, we are going in a clockwise direction, so we go to Herne next, and then we go back up to Leuchars, so then we go west. So here is our completed table. So we've got Heathrow, northeast, Herne, east, and Leuchars, west, which was also added to the table. Question number 4. A large college produces 3 magazines. One magazine is about green issues, one is about equality, and one is about sports. A student at the college is selected at random, and the events G, E, and S are defined as follows. G is the event that the student reads the magazine is about green issues. E is the event that the student reads the magazine about equalities. S is the event that the student reads the magazine about sports. The Venn diagram, what we see here, where P, Q, and R and T are probabilities, gives the probability for each subset. For part A, we have to find the proportion of students in the college who read exactly one of these magazines. Well, that's G only, plus E only, plus S only. So, for part A, the probability that we read exactly one magazine, that's J only, 0.08, plus A only, that's 0.09, plus S only, 0.36. So if we work all of this out, we get 0.53. Now, for part B, no student reads all 3 magazines, and the probability of G is equal to 0.25. We have to find the values of P and Q. Well, if no student reads all 3 magazines, that would suggest to us, for part B, that the probability of J and E and S is equal to 0. So the probability that we read all 3 magazines is equal to 0. And we also know that the probability of G is equal to 0.25. So when we come to find the value of P, if probability of green and equality and sports is equal to 0, well, that of course is what P is. And so therefore, the probability of green and equality and sports is P, which of course is 0. So P is equal to 0. And now when we come to find the value of Q, we know that the probability of G is 0.25. Well, what's G equal to? That's 0.08, 0.05, Q and P added together. So, the probability of G, we have 0.08, Q, P, and 0.05 added together, and this is all equal to 0.25. And knowing that P is equal to 0, we have 0.13 plus Q plus 0 equals 0.25, from which we can conclude Q is equal to 0.12. We have found the value of P, we have also found the value of Q. Now, for part C, given that the probability of S given E is equal to 5/12, we have to find the value of R and find the value of T. For the part C, we're given S given E is 5/12. Well, to do this, what is the probability of E? Well, the probability of E, that's 0.05, 0.09, P and R all added together. So E would have probability R plus P plus 0.09 plus 0.05 added together, and S, that's, well, if we take a look at S, we want S given E, so we're given E, and of that, what includes S? That is region here, P plus R, or R plus P. And this entire result is equal to 5/12. So, we are using this information here. Hence, we have this sum equaling 5/12. Now we know what P is. P, we were told, is 0. So we have on the bottom R plus, well, here we've got 0.09 plus 0.05, that's 0.14, that's what we have on the bottom, and on the top we have R, and this is equal to 5/12. If we multiply R by 12 and 5 by R plus 0.14, we end up with 12R equals 5R plus 0.7. 7R is 0.7. R is equal to 0.1. And now that we know what R is, if we go back to the Venn diagram, we need to find the value of T. Well, the sum of probabilities is equal to 1, so each of these values added together is equal to 1. So for the next part of the question, the sum of the probabilities is equal to 1. So if we add up all these probabilities shown in this table, we have 0.08 plus 0.05 plus 0.09 plus Q plus P plus R plus 0.36 plus T. This is all equal to 1. So if we tidy all of this up, replacing Q, P and R with what we've found, we have 0.08 added to 0.05 plus 0.09 plus 0.12 for Q plus P, which is 0, plus R, which is 0.1 plus 0.36 plus T. This is all equal to 1. So we've got 0.8 plus T equals 1, from which we can conclude T is equal to 0.2. Now for part D, we have to determine whether or not the events S and not E and G are independent. Show you working clearly. Well, if we go back to the formula book, we know for independent events the probability of A and B is equal to the probability of A times the probability of B. Well, instead of us having an A, we have an S and E dash. And instead of us having B, we have a G instead. Let's begin by writing out that formula. So, for independent events, probability of A and B is probability of A times probability of B. So let's begin by writing out the probability of S and not E. So if we go back here, S and not E, well, that will just be S only, 0.36, and of course we add on this Q over here. That doesn't include the E. So everything that's S and not E, that's 0.36 plus Q. Now we know the value of Q, that's 0.12. So we've got 0.36 plus 0.12, which is 0.48. So that is probability of S and not E. Now, the probability of G, we were told in the question, the probability of G is 0.25. So the probability of G is 0.25. Perhaps if we use colours to help us coordinate, we have A over here, so A goes here and B is over here. So now the probability of S and not E and G, well, let's again colour coordinate this. what this is equal to, if we go back to the question, we have S and not E and G, so this is just equal to Q. So we know that this result is equal to 0.12. So, using our formula for independent events, probability of A and B, well that's S and E dash and G, so that's 0.12. We're questioning, does this equal probability of A, which is 0.48, multiplied by probability of B, which is 0.25. Well, 0.12 is definitely equal to 0.12. The left hand side and the right hand side are equal. S and D dash and G are independent events. Question number 5. The heights of females from a country are normally distributed with a mean of 166.5 centimeters and a standard deviation of 6.1 centimeters, and given that 1% of females from this country are shorter than k centimeters, for part A we have to find the value of k. Well, if we've got a normal distribution, for part A, we begin by letting the random variable f be normally distributed with parameters 166.5 and variance 6.1 squared. Now, we know from the question that 1% of females from this country are shorter than k centimeters, so the probability that f is less than k is equal to 0.01, 1% in other words. What we need to do is find the value of k. Well, let's draw a quick diagram. Got a normal distribution. The mean 166.5, and for some value of k we have a probability of 0.01. Perhaps if we show k in a different colour, like black, we know here we have a probability of 0.01. That is what we see here. Now, we can standardize this to help us find the value of k by finding the equivalent z value. So we've got the same distribution. This time we're going to convert our values to z. Now, in the formula book, we're given 1% as our probability, and the equivalent z value is 2.3263. Of course, we have a minus because we're on the left of this zero. So the equivalent z is minus 2.363. Now, if we standardize, we can standardize using x minus mu over sigma equals z. So we've got k minus 166.5 over sigma, which is 6.1. This is equal to minus 2.363. What we need to do is find out the value of k. So if we find out what the value of k is, we've got minus 2.363 times 6.1 plus 166.5. It turns out we get k equals 152.0857. So that's what k is. And now for part B, we have to find the proportion of females from this country with heights between 150 centimeters and 175 centimeters. So, for part B, we have to find the probability that f is in between 150 and 175. Let's draw a quick diagram to help visualize what we need to work out. We've got our mean over here. Here somewhere we've got 150. Here somewhere we've got 175. Our mean is 166.5. What we're required to do is find this probability. So if we find that probability on our calculator, if we go to the distribution section, we have a normal CD. The lower limit is 150. The upper limit is 175. Sigma is 6.1. Mu is 166.5. So it turns out we get 0.91484, etc. Now for part C of the question, a female from this country is chosen at random from those with heights between 150 centimeters and 175 centimeters. We have to find the probability that their height is more than 160 centimeters. So if we go back to our diagram for part C of the question, what we've worked out in part B is the probability that the height is in between 150 and 175. And what part C is asking us is, what's the probability that f is greater than 160 given that the height is in between 150 and 175. Well, we've already worked out this result here. So, what this is equal to, on the denominator we've got probability that we've got a height in between 150 and 175. And of those, how many are greater than 160? Well, 160 is over here somewhere. So let's just move this down a little. And what we're after is everywhere greater than this. But we need to stop off at 175. So we're after the probability that the height is in between 160 and 175. So this is what we are after. So if we work all of this out, Well, I've already worked out one of these values over here. What I have on the bottom is the 0.914, etc., which is what we see here. And on the top, we can work out that value using our calculator. So, if I store this into A, because I'll need to use it later on, my lower limit is 160, my upper limit is 175, the rest of the parameters are the same. So on the top, we've got 0.774, etc. So now, if I do that divided by A, what we end up with as our probability is 0.847, etc. And now for part D. The heights of females from a different country are normally distributed with standard deviation 7.4 centimeters. And Mia believes that the mean height of females from this country is less than 166.5 centimeters. Mia takes a random sample of 50 females from this country and finds the mean of her sample is 164.6 centimeters. We have to carry out a suitable test to assess Mia's belief. You should state your hypotheses clearly and use a 5% level of significance. Well, over here, we need to use a different distribution. We've got a normal distribution, but we'll have a different random variable. So, for part D of the question, we will let the random variable x equal the heights of females from this second country. Now, if we go back to the question, what she is doing in this question is she's got her population and then she's finding the means of a sample of 50. So that suggests to us we need to think about a sample mean. And so if our random variable x is equal to the heights of females from the second country, x bar then is normally distributed with parameters. Well, what would the mean be here? The mean here would be 166.5. And so the variance now, we've got our standard deviation, which is 7.4, and we need to divide this by square root 50. So, here we've got 7.4 over square root 50, all squared. This result here is, of course, our variance. Now what we're doing is we are seeing if the mean is less than 166.5, and what we found is she found from a sample of 50 the mean of that sample was 164.6. So with our hypothesis test, we begin by letting H0, mu is equal to 166.5, and our alternate hypothesis, H1, mu is less than 166.5, and this is what we're testing, whether the mean now has changed. Now, what we'll do is we'll find the probability that x bar, the mean, is less than 164.6. So let's work this out. here we've got our diagram. 166.5 goes here. Here we've got 164.6, and then let's calculate this probability. So if we go to the distribution section, normal CD, the lower limit is something really small, choose something like 1,000,000. Upper is 164.6. Sigma, well, that will be 7.4 divided by square root 50, and the mean is 166.5. So it turns out here we get 0.034. So the probability that x bar is less than 164.6, that's equal to 0.0347, etc. Now this value over here is less than 5%. Remember, in the question, we are testing at a 5% level of significance. And so 5% would be up to here somewhere, so this here is 5%. We are in the region where we reject H0. So we reject H0, and so there is evidence to support Mia's belief. Question number 6. The discrete random variable x has the following probability distribution. We've got different values of x and their associated probabilities. A, b and c are distinct integers where a is less than b, which is less than c, and all the probabilities are greater than 0. For part A, we have to find the values of a, b and c, showing our working clearly. So for part A, we can use the fact that the sum of the probabilities is equal to 1. Now, we need to add together log base 36 of A with log base 36 of B with log base 36 of C. And all of this is equal to 1. We can use the addition law of logs to simplify this. We have log base 36 of A, B, C equals 1. 36 to the power of 1 is equal to ABC, from which we can conclude A times B times C is equal to 36. We need 3 numbers which multiply to give 36. Now, of course, here A, B and C must all be greater than 1. The reason for this is log base 36 of 1 is equal to 0, and we know that all the probabilities are greater than 0. And because all the probabilities are greater than 0, it follows then A, B and C must be greater than 1. We also know A, B and C are distinct integers. That means they're all different integers, and A is less than B, which is less than C. So we need numbers which multiply to give 36. So if we think about what 36 is, 36 is equal to A times, well, let's think of about numbers which multiply to give 36. We can factorise using our calculator. 36 is equal to 2 times 2 times 3 times 3. We need three numbers which multiply to give 36. Well, we could have 2 times by 3 times by 6. They're all different numbers. These three numbers here are all distinct. We have distinct integers, and so with a being less than b being less than c, a will be the smallest one, followed by b, followed by c. A is 2, b is 3, c is 6. And now for part b of the question, the independent variables x1 and x2 each have the same distribution as x. We have to find the probability that x1 is equal to x2. Let's create a new table. Here we've got our probability distribution. Probability of x1 is equal to the probability of x2. Now, if we were to find the probability that x1 equals x2, well, we'd have to multiply this by this, then add on this times this, and add on this times this. In other words, we've got log base 36 of a squared. We also have log base 36 of b squared, and then we've got log base 36 of c squared. I'm working this out. We've got log base 36 of 2 squared plus log base 36 of 3 squared, and then we've got log base 36 of 6 squared. And if we work all of this out, we have log base 36 of 2 squared plus log base 36 of 3 squared plus log base 36 of 6 squared. We get 0.3814, etc. So this is the required probability.